Let's take a look at the formal definition of probability. It says if E is a subset of S, then the probability of E is written as capital P parenthesis E equals the number of outcomes of E divided by the number of outcomes of S. Remembering S is the original set, kind of like a universe, the situation we're looking at. A short version of this is the number of elements of E, or outcomes, divided by N, and N representing the total number of outcomes possible, while E is just the outcomes that meet that criteria of E. So let's take a look at a simple example. With the simple example, it says, a bag contains 9 tomatoes, of which 1 is rotten. A sample of 1 tomato is selected at random. What is the probability the sample contains the rotten tomato? So we would say the probability of the rotten tomato is equal to, well, there's 9 tomatoes we could select from, but only 1 is rotten. So it's 1 out of 9. That's a very basic case. Let's take a look at a case where a complement rule is needed. A complement rule says if I'm looking for an event, then the probability of that event is equal to 1 minus P, the complement. So if I want the probability of E, it equals 1 minus the complement of E. Okay, let's take a look at this first example. There are 4 people, Sam, Tam, Bam, and Zam. What is the probability of not selecting Tam? Well, if I am looking at not Tam as my probability, then I think about the probability of the whole, which is 1, minus the probability of getting Tam. And I'm assuming here that I'm just selecting 1 out of the 4. So the probability of not getting Tam is equal to 1 minus 1/4. 1/4 is the probability of Tam. That means the probability of not Tam is 3/4. And we could have seen that that was 3/4 by looking at the fact that there was Sam, Tam, Bam, and Zam. If I didn't want Tam, then I only wanted Sam, Bam, and Zam, so there's 3 out of 4. In this next example, you might be surprised by the result. It's going to have to do with birthdays. It says, if there are 4 people in a room, what is the probability that at least 2 people were born on the same day? Don't worry about the year though. We're just focusing on the fact that someone was born on the same day for the month and the day being the same. We want to find the probability at least 2 are born on the same day. At least 2 means that we could have 2 born on the same day, 3 born on the same day, or 4 born on the same day. So to calculate 2 being born on the same day, and then 3 born on the same day, and then 4 born on the same day is a lot of work. Instead, we can look at the complement. The complement of that is none are born on the same day. The calculation for none being born on the same day is a fraction where the first person could be born on any day of the year. Then the next person can't be born on the day that that first person has. So there's 364 days the second person could be born on. The third person could be born on 363 days. And the fourth person could be born on 362 days. Well, really they're only born on 1 day, but they have 362 possible days in which their birthday could have been. Okay, so that would represent the number of people or situations that none are born on the same day. It's a number of situations. We need in the denominator 365 to the 4th power. That's the number of arrangements that if we had 4 people and we asked what their birth dates were, how many total answers we could get, and those answers would include people that didn't have any birthdays that were the same, at least 2 were the same, at least 3 were the same, or at least 4 were the same. So 365 to the 4th includes all of those, while the numerator is just those born where none of them are on the same day. So this fraction gives us the decimal 0.98364. When I subtract that from 1, I get 0.016, which tells me that there's a 1.6% chance that out of a group of 4 people, at least 2 were born on the same day.